Hi there, this is Dr. Matthew J. Traum. Welcome to the first video of the 7th lecture of the Engineering Design course. Like I do with every one of these lectures as I start them, let me just give you a brief explanation of how things are organized. So I usually like to speak for about 7 minutes, which is the length of time that people can usually keep their attention focused on the lecture content. So after about 7 minutes, I'll take a quick break, end this video, and let you guys go off and relax for a little bit. And then when you're ready, you can come back and start the next video. And we'll keep doing that until we exhaust the entire slide deck. So that's how things are organized. Anyway, with no further ado, let's hop into this lecture. We're going to talk today about product performance specifications. And this slide gives kind of an overview of all the different attributes of performance specifications. So first, we've talked quite a bit in previous lectures about customer needs, customer need statements, converting customer need statements from something qualitative into something that's quantitative. And it's that quantitative thing that is the specifications. So it's important to realize that customer needs are not specifications. Customer needs provide some guidelines with respect to objectives and functions for what a design must do, but ultimately your performance specifications set precise quantitative limits on precisely what your design must achieve. So there's a big difference there between kind of the qualitative customer needs statement and the very, very quantitative specifications. And it's usually up to the design engineer to convert the qualitative customer needs into the quantitative specifications. So we'll talk a little bit more in later slides about how to do that. But the next attribute is, since performance specifications set a target range, a range for performance, they should not be too narrow. So when possible, you don't want to overly constrain the design by just giving a single value. The height must be X or the weight must be Y. You want to give a range, and that range allows the engineering designer to be flexible and be creative in their various possible solutions. So remember, it's much better to give a range than it is to give an exact numerical specification. The third attribute is performance specifications ultimately are used later on in the design process, and we'll see that in future lectures. They're used later on in the design process to quantitatively evaluate proposed solutions. And really what you're doing is you're using the range of specifications, or the range of the specifications that are set in this stage of the design process, and you're comparing the performance of possible solutions to those specification ranges. So does a particular solution fall within that range? And if it does, then it's a viable solution, and if it doesn't, then you have to throw it out or at least discount it compared to other possible solutions. So this step turns out to be quite important because it provides kind of the method of checking to make sure that the design solution that you ultimately come up with does in fact perform as you've specified that it should. So keep that in mind, that this is a critical step for future steps in the design process. And finally, we place emphasis on the performance of a solution, not necessarily particular components. Now, we've talked a little bit before about different ideation, creative ideation opportunities where you think about different components that you can buy commercially off the shelf to achieve particular performance. So that's a creative ideation approach. But ultimately, when you're setting specifications, you don't want to specify solutions. You don't want to say, for example, I want to use an aluminum rod, right? When you could just say, I want the device to be 1 meter tall, right? Not a 1 meter tall aluminum rod, but just 1 meter tall. Because if you over-specify by selecting specific solutions to problems, again, you're over-constraining the design problem. You're preventing the engineering designer from being able to be as creative and flexible as possible in exploring the design space. So those are the 4 attributes of product performance specifications. Now on this next slide, I'm going to just outline the 4 steps for the procedure to set product performance specifications. And in subsequent slides, I'm going to talk about each of these in detail, but I want you to see kind of the big picture of the 4 steps and how they all fit together. So first, you're going to consider different applicable levels of solution generality. Second, you're going to determine the generality level at which to operate. Third, you're going to identify the required performance attributes. And then finally, you're going to state as succinctly and precisely as possible the performance requirements for each attribute. So those are our 4 steps, and now we're going to talk about each one of them in a bit more detail. Okay, so the first step is to consider different applicable levels of solution generality. And what I've done here is essentially create this graphic around the customer need that this device that we're going to create hovers. So the customer need is it hovers. And to think about the level of solution generality, if we have too general a specification, it allows the designer to suggest a range of possibly inappropriate solutions, so just too many wild and crazy solutions. So over here in too general, I've got various things that hover, right? Like a hummingbird hovers, a Harrier jet hovers, this weird little hoverboard hovers, and a balloon hovers, right? But those are all so disparate and so desperate from each other that they really don't represent a cohesive, meaningful design space. So that's an example of a specification that essentially was set too generally. The other extreme is if you set your specification too specifically, and that essentially removes all of the design engineer's freedom. So if you're too specific, you say it hovers, and you set your specification too specifically, you essentially end up with 3 helicopters, right, that maybe are slightly different in color, maybe they're different in the number of blades, but overall they are so similar to one another that the design space is essentially non-existent. There's only one solution, which is a helicopter. So in that case, you set things too precisely. So anyway, you want to classify level types from most general down to the least general. And the way of thinking about doing that is to start with product alternatives, which is the most general. Right in the middle is different product types, and then the least general is specific product features. So that's kind of the range from too general to too specific in terms of applicable levels of solution generality. Okay, so I've gone over 7 minutes here, so I'm going to take a quick pause. You guys get to take a break, and when you're ready, come back and watch the next video, and then I'll see you in a moment.